Hey, fans of hypothetical scenarios and crazy compilations about the cosmos, it's another special What If episode. I mean, they're all special if you ask me. Today, we're focusing on the second largest planet in our solar system, Saturn. I'm the host of What If, Peter, and I'm pretty excited to get to today's collection of Saturn stories. We know from your comments that Saturn is your favorite planet of all, and no wonder. It's a fashion icon with those spectacular rings. I mean, Jupiter's in the running with its immense size and big red spot, but I gotta say, Saturn is my favorite too. I think we have a lot in common, Saturn and I. It spins really fast, it's flattened at the poles, and has a bulge in the middle. And it's particularly gaseous. We're basically twins. Anyway, to discover what would happen if you fell into this gas giant, well, I sent our roving animated smart aleck, Chase, there to find out.
Help!
Welcome to Saturn, the most beautiful and violent planet in our entire solar system. Saturn is famous for its magnificent rings.
Saturn is the it girl of the solar system. What is the point of an accessory if it's not visible?
Ugh. Thank you, Chase.
No problem. Thank you.
He does have a point. Scientists know a lot about what happens on Saturn, but they're pretty unclear on why. For one, Saturn radiates twice as much energy into space than it receives from the sun. That means it must have an internal heat source. Do we know what that is? Absolutely not.
Oh, I bet it has something to do with the composition of the core.
Well, Chase, we're sending you to find out. Yeah, that's right. Today, Chase is falling straight into the middle of Saturn.
Oh, see that cloud pattern on Saturn's North Pole? It's like a massive swirling hurricane, like the ones you have on Earth. But this one is shaped like a hexagon.
Hexagons, rings, Saturn has every shape.
What about triangles?
Not triangles.
Rectangles?
No more talking for you.
Circles?
Saturn's cloud hexagon is huge. It's 14,500 kilometers long and 29,000 kilometers wide. That's over 6 times the width of mainland USA. That should give you a sense of just how big this entire planet is. It's the second largest in the solar system and 10 times as wide as Earth. Oops, almost forgot.
Unmute me right now! Thank you! I did not appreciate that, and you almost forgot the coolest part! A few years ago, that windstorm changed color from blue to golden. Scientists aren't really sure why, but I know why. Remember that hit internet sensation about the black and blue dress?
You mean the white and gold dress?
Literally nobody sees white and gold. Anyways, that meme got to Saturn, and Saturn's PR people wanted in.
Ugh, I shouldn't have unmuted you for that. But yeah, Saturn's northern winds are subject to pretty wild weather phenomena. Another big one, a violent storm that covers the entire planet. That's right, every 30 years, Saturn is taken over by the Great White Spot. The last one happened in 2010, so Chase should be safe to fly into Saturn. He'll have to come back in 2040 to see the Great White Spot.
Rico, mark that in my calendar, please.
Now, Saturn's most distinct feature is its huge rings. They're over 280,000 kilometers across, but only 1 kilometer thick. To the naked eye, they're practically two-dimensional.
And I'm gonna fly right through them. Of course, I could fly around them, but come on, that's like going to Paris and not seeing the pyramids. You gotta do the touristy stuff.
These rings are made up of millions of particles of ice, debris, even the remnants of dead planets. Pretty tough to navigate.
Pfft, you always doubt me, Peter.
Well, in my defense, you do die pretty often. These rings are named in order of discovery, which makes the order pretty confusing. Chase will fly through E ring and then G, F, A, B, C, D. E ring is the furthest from Saturn, and its material is almost entirely provided by ice and water from Enceladus, a moon of this gas giant. Enceladus has a hidden ocean beneath its icy surface, and it's known for its geysers that shoot ice particles into space. These particles often get caught in Saturn's rings, making E-ring appear brighter and bigger.
And this moon is tiny. We're talking 7 times smaller than Earth's moon. But even small moons can have an enormous effect. See, Tiffany? Size doesn't matter! Whoa. That is beautiful.
It's true, Saturn's F-ring is particularly stunning. It's thin and narrow, but it's also wild and unpredictable. It doesn't look as smooth as the other rings of Saturn. That's because it's mostly made of icy particles, and these particles are being pulled by Saturn's 2 moons, Prometheus and Pandora. These moons keep the ring together, but they also mess with it, creating twists, clumps, and even braids in the ring.
That was my favorite ring so far. All right, next up, A.
The A and B rings are the 2 brightest rings. They're separated by the Cassini division, which is the largest gap between any of Saturn's rings. The Cassini division is over 4,800 kilometers wide, and it's likely caused by Mimas, Saturn's smallest and closest moon. Mimas has a modest radius of 200 kilometers, and it doesn't even have a fully round shape.
Some distinguished scholars say that it was the inspiration for the Death Star.
No, you are saying that. Mimas was not the inspiration for the Death Star, as the first Star Wars, Episode 4, A New Hope, it came out 3 years before the Voyager spacecraft captured detailed images of Mimas. But even this little moon is enough to disturb the particles in Saturn's A-ring and nudge them out of their orbit with its gravitational pull, creating something as vast as the Cassini division. But enjoy this gap while you can. Mimas has begun to drift away from Saturn, and without it affecting Saturn's rings, in some 40 million years, the Cassini division will close.
You know, it's awesome that the balance of orbits and moons and gravitational pulls produces something as beautiful as Saturn's rings. It really makes me think about the way that we're all a web of interconnectivity, how even small things can have an unexpectedly huge impact in people's lives.
Wow, Chase, that's really profound.
It's like that time that Rico forgot to warn me about a crater on Pluto and I fell and broke my neck. One little f***ing robot, so much trouble. Anyways, I'm about to fly through C-Ring, and I gotta be mega careful because Titan, Saturn's biggest moon, creates these gravitational tsunamis.
It's true. Titan's gravity creates a 2-kilometer wall of ice particles that orbits around the ring. Scientists call them tsunamis, but they move pretty slow, so Chase will be fine.
All right, made it through C. Just one more ring to go, and then I'll begin my descent into the atmosphere. Check it out, I got this sick space balloon that'll help me descend into the atmosphere. Caught it for half off from the returns bin. Pretty sick.
Now, the last time a spacecraft approached Saturn, well, it didn't end well for it. The Cassini spacecraft orbited this giant for over a decade. And finally, in 2017, scientists intentionally crashed it into the planet so that it wouldn't contaminate any potential habitable moons. They literally vaporized the entire ship. The debris might even be part of these rings now.
Wow, that's really poetic, like bodies returning to the soil. Of course, none of that's gonna happen with me. Me and my clearance balloon plan on surviving this one. I peg our chances at around 80%. Oh, is that a rip? Duct tape fixes that.
Saturn is mostly hydrogen and helium, which makes Saturn the only planet less dense than water. Yeah, if you threw it into a giant lake, it would float.
Rico, read the atmospheric composition.
Calculating. 75% hydrogen and 25% helium with traces of methane and water ice.
You needed a calculation for that? What are you doing with your free time?
To get all the way to the center of Saturn, you'd have to first go through the thick gaseous atmosphere, and then through a layer of liquid hydrogen, then through metallic hydrogen, and finally reach the incredibly rocky core. Now, you'd be passing through Saturn's troposphere, and it's freezing. The temperature here is about minus 175 degrees Celsius.
Yeah, I'm feeling the chills. Okay, let's go.
Yeah, you entered the atmosphere right around Saturn's equator, which is where the winds are the fastest. Not the best move. The gas planet rotates on its axis once every 10 hours and 33 minutes, which is incredibly fast for such a large planet. This speed means that Saturn actually bulges a little around its equator, like me, and concentrates jet streams in that area. Add so much heat rising from Saturn's interior, and you get high energy winds that reach up to 1,800 kilometers per hour. That's 4 times as fast as the fastest hurricane winds on Earth. You do not want to get caught in anything like that.
Rico, slow me down!
Calculating.
Calculating? What are you calculating?
Slow down initiated.
Oh, I'm gonna be sick. Oh god. Rico, next time we're about to enter a tormenting wind place, just slow us down to begin with.
Manual override needed to activate wind countering.
Ugh, you're about as helpful as usual. Oh god, what is that smell?
You're currently in Saturn's top cloud layer, 100 kilometers below the top of Saturn's troposphere. The clouds here are almost entirely ammonia and ammonia ice, which have a notoriously bad, pungent smell. And the temperature here is about minus 250 degrees Celsius. All this ammonia in Saturn's cloud tops is what gives Saturn its yellow hue.
You know, other than the horrible smell, the freezing temperature, and Rico's inability to use a calculator, this place isn't that bad. We moved away from the equator, so the wind's a little slower. The pressure is, Rico, give me a pressure reading.
400 millibars.
That's like 40% of Earth's pressure. Honestly, I'm chilling.
After the stinky ammonia clouds comes the second cloud deck, made of ammonium hydrosulfide clouds.
Rico, another pressure read.
1.7 bars.
Oh, okay, that's not that bad. That's like just a little bit more than Earth. All right, let's keep going down.
170 kilometers below the troposphere. Temperature reading, minus 70 degrees Celsius.
Oh god, it smells even worse here. Oh god, what is going on?
Ammonia hydrosulfide detected.
Oh great. My 2 favorite scent combos, together at last, urine and fart. Chef's kiss.
At this depth, the pressure is about 5 bars. That's like scuba diving in a depth of about 35 meters. Not pleasant, but it's not unimaginably painful either.
Oh, my sinuses are starting to burn. If I just don't use my nose, I can get through this.
As the pressure and temperature steadily increase deeper into Saturn's atmosphere, more complex compounds form. The upper layers of Saturn only have ammonia ice, but as you go deeper, you'd be surrounded by ammonium hydrosulfide. Sadly for Chase, complex compounds don't always mean better smelling ones.
Yeah, I'm still waiting for Chanel number 5 to make a planet, but it's getting a little warmer in here, so soon it'll feel like a tropical vacation.
You are 220 kilometers below the troposphere. Temperature reading, 0 degrees Celsius. Pressure reading, 10 bars.
This is Saturn's thickest cloud layer. It spans 10 kilometers and is mostly made of water ice and some ammonium droplets.
What's happening?
High pressures causing balloon deflation.
Okay. So I guess when I came up with this balloon idea, I was thinking about descending into the planet. And I forgot to think about ascending on the way back out. Yikes.
The cloud layers and outer atmosphere are just 17% of Saturn. The other 83% is almost entirely made up of liquid hydrogen, with a relatively small rocky core at the very center. This deep into Saturn's atmosphere, the pressure is extremely high, and it's constantly increasing. All this incredible pressure does one interesting thing. It turns hydrogen gas into a liquid. So just 500 kilometers below the troposphere, the pressure is 1,000 times higher than it is on Earth.
It's really unpleasant. It's hot and it hurts. It's hot, it's so hot, and it's a liquid, not a gas. It's hot and it's counterintuitive too.
That's just the power of 1,000 bars of pressure.
Rico, what is it, temperature? Rico, calculate temperature, please.
Calculating. 730 degrees Celsius.
Okay, and how's my balloon doing?
Heat and pressure accelerating balloon deflation.
Oh, that's not good. That's not good at all. That's not good for Chase Boy. Oh, no.
17% inflation.
Oh, man, if only real inflation rates would come down this quick, I could buy eggs again.
13% inflation.
Okay, you can stop now. Seriously, next time I'm installing a reinflate feature, or a go up feature, or a grappling hook. Something!
0% inflation.
Huh? Ah!
Well, Chase is currently falling through 60,000 kilometers of liquid hydrogen. As he goes deeper into Saturn, the pressure will become even more unbearable. Soon, it'll get as high as 2 megabars. That's 2 million times the pressure you experience on Earth. At this point, atoms are under so much pressure that they can't maintain their shape. The pressure literally squeezes the atoms so much that their electrons create an electrically conductive layer in the planet, metallic hydrogen. This layer is 30,000 kilometers thick and surrounds Saturn's rocky core. But let's see if Chase makes it that far.
Temperature reading 5,700 degrees Celsius.
Oh, Rico, do not malfunction. If anything in this suit zaps, I'm gonna get fried. Oh, Rico, we found it. Oh, man. Oh, God. Okay, let's just read the composition and then get out of here, okay? The first people to see Saturn's core. This is awesome. Oh, Rico, come on, help! Rico, just get the retract. Oh, that wasn't so bad. That was just.
Okay, well, as expected, that didn't turn out very well for Chase. It never does. If you like that guy, he's got his own channel on YouTube called, appropriately, Chase Dies in Space. You could subscribe to that channel to see his hijinks. Frankly, I'm trying to get him off my channel. He's hogging all the airtime. Okay, up next, I think you know by now that Saturn is a gas giant and doesn't officially have a surface. So my asking, why can't you walk on Saturn, has pretty much already been answered. But let me take you on a detailed trip through Saturn's layers. I mean, forget Chase. What would happen if you tried to walk on Saturn?
With its huge rings of ice and dust, Saturn is one of the solar system's most iconic planets. It's beautiful, really. But what's it hiding behind those bright clouds? Well, you're about to find out by taking a stroll on the gas giant's surface. If you can. What would it be like to fall through Saturn's atmosphere? How soon would extreme conditions bring you to a frozen end? And if somehow you did make it to the surface, what would you find? This is What If, and here's what would happen if you tried to walk on Saturn's surface. About 1.2 billion kilometers away from where you're standing right now sits Saturn, the sixth planet from the Sun. About 9 times wider than Earth, it's the second largest planet in the solar system. Circled by its signature rings of dust, ice, and rock, Saturn also has 83 moons orbiting it. 63 of them known and 20 of these awaiting official confirmation. And with an atmosphere mostly made up of hydrogen and helium, this planet is considered a gas giant. And this would be important to keep in mind if you plan to take a leisurely stroll along its surface, because you could just end up falling right through it. As you approached Saturn, you'd be the first human to take in the glory of its rings and its swirling atmosphere in person. Along the way, you'd pass a few of Saturn's moons, like its outermost moon, Iapetus, the icy Enceladus, and its biggest moon, Titan. You'd make a note to check that one out on your way back home. But for now, you have a date with Saturn. Soon, you'd be making your way through its massive ring system. This would mean you're getting close. Saturn's rings don't even stretch as wide as the distance between Earth and our own moon. You'd fly past each ring in an order that would scramble your understanding of the alphabet. You'd go from the E ring to the G ring and then rings F and A. After that, there's a gap known as the Cassini division. Past it, you'd be on to rings B, C, and D. Yeah, it might sound like whoever named these rings didn't know the alphabet too well, but that's not true. Saturn's rings were just named in the order that they were discovered. You'd pass a lot of stuff inside the rings. Their components range in size from the tiniest grains of ice dust to objects like comets, asteroids, or pieces of former moons that are as large as mountains back on Earth. Finally, you'd make it to the D ring, and you'd be hovering just above the planet itself. Nothing left to do except make your descent. Traveling down to an altitude of about 1,400 kilometers, you'd find yourself surrounded by auras of red and purple. They'd look so different from the ones we have on Earth because of the highly energetic forms of hydrogen in Saturn's atmosphere. Your fall through would suddenly get more exciting, too. You'd begin to get thrown around by powerful gusts of wind. In the upper atmosphere over the planet's equator, winds can reach speeds as high as 500 meters per second. That's almost 5 times stronger than the strongest hurricane force winds on Earth. Yeah, so maybe the equator's not the best place to descend. You'd try coming in for a landing elsewhere, like Saturn's North Pole. Well, this wouldn't be ideal either, because as you descend, a hexagon-shaped storm would be brewing below you, and it would be huge. Spanning about 30,000 kilometers across, you could fit about 2.5 Earths inside of it. Yeah, at least the winds here would be more favorable, but just by a little bit. At the North Pole, wind speeds only reach about 90 meters per second. And I hope you dressed warm enough for Saturn's weather, because the gas giant's troposphere has freezing cold clouds of yellow ammonia. The temperature here is about minus 250 degrees Celsius. Don't think that sounds too bad? Well, good for you, because that's 160 degrees colder than the most frigid temperature ever recorded on Earth. Now, you'd find things starting to warm up a bit as you continued to descend. Next, you'd fall through a layer of light brown ammonium hydrosulfide clouds, followed by normal clouds made of water. Eventually, things would heat up to the more comfortable temperature of 0 degrees Celsius. But that wouldn't mean that the conditions around you would be comfortable. Temperatures would climb higher and higher, and at these lower levels of the atmospheric pressure would be as intense as it is in the Mariana Trench, the deepest part of our oceans. At some point, you'd be wondering if you'll ever reach Saturn's surface. Well, you'd be disappointed to learn that you kind of already did. It just wasn't solid. Technically, the surface of this gas giant exists where the atmospheric pressure is equal to that of sea level back on Earth. So it was way back up in the freezing cold temperature. There's not much you could look forward to now except continuing to fall straight toward the center of the planet. Of course, the pressure and the temperature would be climbing higher and higher. Soon, you'd find the pressure so high that all the gaseous hydrogen and helium you've been surrounded by would turn into liquid. Yeah, hope you brought a heavy-duty umbrella that can handle helium rain. But that's my bad. I should have warned you about this before you stepped out of the spaceship. Okay, by now, you'd be near the center of Saturn. The planet's molten rocky core could be about 10 times more massive than Earth's, and conditions would be beyond intense. Here, it could be as hot as 11,700 degrees Celsius, with pressure over 1,000 times what you experience on Earth. Yeah, maybe going for a quick stroll on Saturn wasn't such a smart idea. You'd be thrown into an environment so hostile that it would freeze you, then burn you, then crush you under the planet's immense pressure. You wouldn't have a good time. And you didn't even get a chance to walk on Saturn, because as you found out, this gas giant doesn't have a hard surface. What a bummer. You know, the only way you could survive this trip is if you had a special what-if certified spacesuit. You know, the kind that still needs to be invented. Now, if you did somehow manage to escape from Saturn, you could make a quick stopover somewhere a little more manageable, like Saturn's moon, Titan. Approaching this moon, you'd find that it's larger than our own moon and even bigger than Mercury. Titan's not just some boring rock either. Soon, you'd be enveloped by its hazy gold and orange atmosphere of nitrogen and methane. The thick haze around you would look a lot like smog back on Earth. But the worst part is, once you get close to the moon's surface, the atmospheric pressure would make you feel as if you were diving 15 meters deep in the ocean. And at minus 180 degrees Celsius, it would be bone-chillingly cold. But the good news is after all that falling back on Saturn, you'd finally be able to stretch those legs out and work on your step count. Yeah, you'd go for a walk along Titan's rock-hard water ice. Strolling along Titan's surface, you'd encounter all kinds of interesting features. The surface itself would be dark and covered in what would first seem like coffee grounds. These hydrocarbon grains would generate massive dunes, almost like the sand dunes back on Earth. And there would be other things that would blow your mind too. You'd discover rivers and lakes, only instead of water, they'd be full of liquid methane and ethane. There would also be volcanoes spewing liquid water instead of lava. Is it just me, or is everything on this moon just slightly off?
Hey, did you know that Saturn floats? Well, we assume it floats. We don't currently have a body of water big enough to test it out yet, but we do know that while it's 95 times more massive than Earth, Saturn is so low density that if you put it in water, it would float. Pretty cool, eh? But how big is the second largest planet in the solar system? If we moved it from its place as the sixth planet from the sun and made it into a satellite of Earth, replacing our moon, what would happen? Is it big enough to touch us? Would the spinning rings act like a buzzsaw and cut right through Earth's crust? Let's find out. A huge gas giant suddenly appears in the sky. You look up and wonder. It's beautiful and terrifying. The second that Saturn replaces our moon in its orbit, Earth would just as suddenly stop being a planet. We would become a moon. Yeah, scientists would need to reclassify Earth. Well, that is, if any scientist or any humans at all could survive this planetary switch, because Earth's days would now be numbered. This is the first few minutes of Earth becoming a moon of this enormous gas giant. But before we get into what happens when Saturn captures our home planet with its unforgiving gravitational grip, well, let's talk about the sheer size of this massive giant. Our moon, the moon, has a radius of 1,740 kilometers. That's just over 1,000 miles. And it's less than 1/3 of the width of Earth. It orbits Earth at a distance of about 384,000 kilometers away. Now, to give you an idea of how far that is, well, you could fit about 30 more Earths between us and the moon. Now, if the moon were suddenly to be replaced by Saturn, it'd be pretty hard to miss. Saturn is 33 times wider than the moon. It would dominate the sky, and the rings would make it even bigger, more spectacular, reaching the edges of the horizon. The scale is enormous. Saturn's rings stretch 282,000 kilometers out from the planet. So they'd be reaching out to us, their edges halfway between Earth and where the moon once was. But Earth would be sitting around Saturn's equator, so you wouldn't see these majestic rings the way we see them in outer space right now. Instead, from down here on Earth, they look just like a thin band. Because despite their incredible width, they're only about 10 meters thick. Now, just because Saturn is a gas giant and made mostly of hydrogen and helium, it doesn't mean it's light and fluffy. Saturn is the second most massive planet in the solar system. It's gigantic and heavy. This gas giant is 95 times more massive than Earth. And remember, Earth is 81 times more massive than the moon. So, according to my calculations, that would make Saturn 7,700 times more massive than the moon. And, of course, you know what massive objects have, don't you? Enormous gravitational pull. Yeah, the moment Saturn appeared in the sky, it would start pulling our planet toward itself. Just like the moon pulls at Earth's oceans and causes tides, well, so would Saturn. But on a scale that would be hard to imagine. The gravitational pull would be thousands of times that of what we're used to. These extreme tidal forces would create enormous bulges in the oceans and seas. The tides would run out to sea like raging rivers and then rush back as waves hundreds of meters high. Ships would be left stranded on the ocean floor and then smashed by the returning water. Cities by the sea would be drowned, decimated. And those gravitational forces wouldn't just be pulling on the Earth's surface. They'd be tugging at land, too. Earth's surface might seem sturdy to you, but it's actually quite delicate when it comes to planetary forces. Every fault line would be stressed past its breaking point. You'd be running from earthquakes that would spread everywhere, and from erupting volcanoes spewing toxic ash and gas up into the atmosphere. There'd be mega tsunamis and mega quakes. Cities would be shaken until they were nothing but rubble. And if any emergency services were left after that, help would not be on the way. Roads would be unpassable, so if you were stuck somewhere in the earthquake, that's it. Nobody's coming to save you. But we're not going to get rid of you that easily. Somehow, you survived this initial chaos, all so that you could witness Earth transforming from our familiar stable planet to the unstable moon of an invading giant. In the first minutes of Saturn replacing the moon, all those eruptions and mega tsunamis would be tearing Earth to pieces. So enjoy the view if you can, because things are going to get a whole lot crazier and deadlier. Again, because of Saturn's enormous mass, Earth would immediately start to be pulled away from our usual trajectory. Like I said, Earth wouldn't be a planet anymore, it would be Saturn's moon, and it would slowly change course and fall into an orbit around Saturn. But it wouldn't be like one of Saturn's usual moons, like Titan. No, Earth would be in a death spiral, getting pulled closer and closer to the gas giant. Speaking of Saturn's moons, you see that gray rock growing in the sky? That's Dione. And yeah, it's bad news for you. Dione is no joke. It's Saturn's fourth largest moon, and it orbits the gas giant at about the same distance as the moon orbits Earth. And don't think you're catching a break in this episode. Dione is on a collision course with Earth. Yeah, Dione is just about 1/3 the size of our moon, but that's still a pretty big rock that's about to hit our planet. Remember the Chicxulub asteroid that wiped out the most gigantic animals that ever roamed the planet? Yeah, well, that dinosaur killer was about 10 kilometers in diameter. Well, Dione is 100 times larger than that. Getting nailed by this moon would hurt. A lot. At first, all you'd notice would be another new moon rising. It would look small and insignificant, but it would grow fast. And that means Dione is getting closer and closer, until eventually it would reach Earth's oxygen-rich atmosphere and ignite into a massive fireball. Yeah, our entire sky would be on fire. And as it falls toward Earth, Dione would pick up speed. Its normal orbiting velocity of 10 kilometers per second would ramp up, accelerated by Earth's gravitational pull. This dense rock moon, 1,120 kilometers across, hitting Earth's surface, would punch a hole deep into Earth's crust and instantly create a country-sized lava crater. At impact, the energy that gets released would send out a fiery shockwave, sweeping around Earth at thousands of kilometers per hour, incinerating everything in its path. Earthquakes would spread out around the world from the impact crater, leveling cities, forests, even mountain ranges. The blowback from the impact would eject a blob of molten core up into the sky, falling back to Earth as searing hot lava rain. If the impact was at just the right angle and velocity, well, the blob of molten rock would be rocketed into orbit to become another moon. But it would be a moon to a very different Earth than we know today. This new Earth would be a fiery, uninhabitable ball covered with red-hot magma oceans. Every single living thing would be killed. The surface of Earth would be sterilized. Some extremely hardy bacteria living in warm volcanic plumes deep at the bottom of the ocean might be the only survivors, and even then, only for a short time. Otherwise, all life would be gone. But hold on, how about some good news? Well, I don't know what your definition of good news is, but at least Earth would be safe from most of Saturn's other moons, especially the largest one, Titan. Titan orbits Saturn at a distance of 1.2 million kilometers, which is 3 times the distance that our moon is from Earth. So if Saturn became our new moon, well, Titan would still be pretty far out in space. Which is fortunate because Titan is 5 times as big as Dione. It's bigger than Earth's moon. A collision with Titan would be a planet-smashing game over for us. But what if Earth managed to scrape past Dione and continue our journey toward Saturn? Well, it wouldn't exactly be smooth sailing from here on in. We'd be heading for a disaster unlike anything Earth has ever experienced. In the unlikely event that you were still alive, well, you'd witness Saturn getting bigger and bigger in the sky, blocking out everything else. Quite a sight. But just because we snuck by one moon doesn't mean we're out of immediate danger. The Saturn has 274 confirmed moons in its orbit, more than any other planet. Some, like Titan, are as big as planets themselves, but others are just 20 kilometers across, like Pan. Lucky for Earth, if Saturn replaced our moon, there'd be just 11 of these moons left in the distance between the gas giant and us. But yeah, Earth would be drifting through an obstacle course. More good news though, most of these moons are small and impact would only be slightly catastrophic. But as Earth passes the 300,000 kilometers away from Saturn mark, we'd be in danger of smashing into Tethys, its 5th largest moon. A collision with Tethys would be similar to a collision with Dione and just as destructive. Even if we snuck by with a close scrape with Tethys, Earth would be rocked by new, even more destructive tidal forces. A close flyby would cause whatever was left of our oceans to slosh around. Waves hundreds of meters high would smash ocean shores. At 180,000 kilometers away, we'd be getting close to another moon of Saturn, Venus, a small moon a mere 392 kilometers wide. An impact or scrape with Venus would further agitate our atmosphere and stress the surface. It might even tear a strip off the atmosphere as it glided by. It's hard to imagine anyone still alive on Earth's surface at this point. The sheer mechanical destruction from earthquakes as the crust is stressed and being pulled by increasing gravitational forces of Saturn would have leveled every structure, thrown up new mountain ranges in a matter of minutes, and turned our seas into boiling water. Something orbiting in space might have a slim chance of making it through all this in one piece, like astronauts trapped on the International Space Station, pulled along for the ride. If they were lucky enough to avoid being crushed by a passing moon or slingshotted into space by gravitational forces, they'd be the only humans left to witness this unprecedented planetary event. Imagine peering out the window of your space station and watching as Saturn's rings get closer and closer, and then suddenly you're in them. From afar, the rings of Saturn look ethereal and airy, but the reality is that Earth would be plowing through trillions of chunks of ice and rock, some the size of dust, others huge boulders. As shards from the rings begin to hit Earth's atmosphere, they'd ignite and turn into flaming meteors. But down on Earth's surface, there'd be no one left to watch the most spectacular meteor shower ever. From a distance, it would look like Earth was a giant eraser, rubbing out an Earth-sized section of the rings. Earth would clear out huge swaths of ring debris and fling others out of their orbit, leaving a trail of flowing dust, rock, and ice. By this point, even a surviving space station would be pulverized, being hit by thousands of ice chunks as it passed through the rings. Nothing humans have ever built for space exploration could survive that. As Earth gets to the 120,000 kilometer range, well, then its trajectory would start to resemble a true orbit. As Saturn's immense gravitational force continues to pull on Earth, it would swing around the massive gas ball, and as it did, it would sink into darkness for hours at a time, thanks to Saturn's enormous shadow. But this cozy orbit wouldn't last very long. Alright, about 3 days into this nightmare, Earth would be at a distance of 71,000 kilometers from Saturn, and it would be approaching a force even greater than crashing through Saturn's rings or colliding with one of its moons. Earth would be reaching its Roche limit with Saturn. The Roche limit is the zone where the gravitational and tidal effects of a large object are powerful enough to overcome the gravitational forces that hold a smaller object together. In this case, Saturn's gravity versus Earth's will hardly be a fair fight. Saturn is just so much more massive than Earth. Like we said at the beginning, 95 times more massive. The gravitational forces holding Earth together in its spherical shape won't be able to resist the force of Saturn's gravity pulling on the side of Earth that's facing Saturn. At this point, so close to Saturn, Earth would literally be pulled apart. Within hours of drifting past its Roche limit, Earth would be ripped into billions of pieces of floating space debris. Some of those might clump together, forming new, smaller objects, but most of them would spread out and turn into a thin band of rocky shards orbiting Saturn. Sound familiar? Yeah, Earth would end up yet another majestic ring of Saturn. That's actually how we theorize the rings forming in the first place, as remnants of small moons or asteroids pulled apart by Saturn as they cross their own Roche limit. Maybe someday in the distant future, intelligent life from another solar system will arrive in ours, and maybe they'll wonder at the mystery of Saturn's newest ring. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling, now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment.
Scientists theorize that many millions of years ago, Mars had rings, just like Saturn. And it looks like the red planet could be due for a new set of rings in the future. How exactly would this happen? Would these rings clutter up Martian orbit? And how soon would these new rings start raining down on Mars? This is What If, and here's what would happen if Mars had rings like Saturn. The four gas giants in our solar system, Jupiter, Uranus, Neptune, and Saturn, all have ring systems surrounding them. Of those, Saturn has the largest. And Mars could join the club. Scientists studying Martian moons Phobos and Deimos suggest that Mars could have had several more moons, including one up to 20 times larger than Phobos. Over billions of years, these moons could have been destroyed and become part of an ancient ring system. Could Phobos and Deimos be next on the Martian moon chopping block? Phobos is orbiting Mars only about 6,000 kilometers from the planet's surface, and it's slowly losing altitude. Eventually, it will reach the Roche limit. This is the closest a big space body can come to a planet and still be held together by its gravitational forces. For Phobos, the estimated Roche limit is 5,470 kilometers from Mars. At this point, the tidal forces of Mars would start to pull the moon apart. After breaking into carbonaceous chondrite meteorites, the stony rocks and dust would form a thin, dark ring around the planet. You'd find that the smaller Martian moon, Deimos, would still exist. That's because it orbits Mars from a comfortable 20,069 kilometers from the surface. Deimos would now mark the outer edge of this new ring. This dramatic reshaping of objects in Mars's orbit could have a big impact on any plans you could have to leave Earth and settle on Mars. Well, maybe not your plans, but more like the plans of your future descendants. Scientists expect that Phobos won't get ripped apart into rings for about 50 million years. The development of rings around the red planet would be a challenge for space flights. It would be difficult to navigate or transport people and resources. Even the most routine trips on or off Mars would become hazardous rides. And a ring system would block some sunlight, having huge effects on our human settlements on the surface. Mars is already a frozen planet with an average surface temperature of minus 63 degrees. So things would get even colder. Let's hope your descendants brought enough warm spacesuits. And even more danger would lie ahead. Eventually, all the objects in the ring would come crashing down on Mars. Big rocks would leave massive new craters on the planet's surface. If it's anything like what happens on Saturn, Martian settlers could face massive storms of rock and dust, falling to the surface at 10,000 kilograms per second. The future of humanity would depend on our ability to create new technologies to blast apart these falling objects before they crush us. Luckily for us, this would happen sometime between 1 million and 100 million years after the ring forms. Yeah, we'd have plenty of time to come up with a solution.
Oh, hey, you like this shirt? Good. Well, this is the point in the show where I usually tell you about our merch store. Yeah, we sell these shirts to civilians like yourself so you can look cool and knowledgeable. And so you can get approached by friends and neighbors who say, no way, you know What If? It's my favorite YouTube channel. Anyway, no pressure, but if you want to be cool, shop.underknown.com is the place to get them. And you should get them now as they're moving at the speed of Saturn. Well, not really. The shipping takes a few days, but lots more stuff in the shop too. Hoodies, stickers, mugs, books, posters. Check it out after the show. Hey, stay tuned to this channel because coming up, we're going to show you what would happen if Earth had rings like Saturn. But right now, let's check out what happens when two worlds collide, like Saturn and Jupiter. It's a little bit like on Seinfeld when Elaine invites George's girlfriend Susan to the movies. Two worlds collide, killing independent George. Only this is a little more disastrous.
The two biggest planets in our solar system in one telescope view. Catastrophe is imminent. If Jupiter and Saturn suddenly were on a collision course, which of the two planets would emerge victorious? How would the composition of these planets affect the outcome? And what impact would this have on the rest of our solar system? This is What If, and here's what would happen if Jupiter and Saturn collided. On December 21st, 2020, Jupiter and Saturn were closer than they've been in nearly 400 years. This legendary event has an epic name, the Great Conjunction. You could see both planets in the same telescope view. They appeared as a single star in the evening sky, but they were still pretty far from an astronomical collision. If the two gas giants came a little closer, it wouldn't be the first time Jupiter has gone head-to-head with another planet, and you can probably guess who won that battle. Both Jupiter and Saturn are almost entirely gaseous, primarily consisting of hydrogen and helium. And while they may have solid cores, there's no sharp transition between the layers. Jupiter would have some significant advantages. It's about 3 times as massive as Saturn, with almost double the volume. And it's moving faster too. Jupiter's rotation speed reaches 13 kilometers per second, while Saturn rotates at just below 10 kilometers per second. But Saturn brings a wild card to the fight. Within its 2 rings, there are at least 150 moons and moonlets. If the planets drew closer together, Jupiter's strong gravitational pull would cause these moons, moonlets, rocks, dust, and ice to accelerate toward it. Some of them would be torn apart. That's what happened when the comet Shoemaker-Levy 9 collided with Jupiter in 1994. Originally, the comet was nearly 2 kilometers wide. But by the time it crashed, Jupiter's gravity had torn it to pieces. And those fragments smashed into Jupiter with the force of 300 million atomic bombs. Yeah, and that heated Jupiter's atmospheric temperature to nearly 40,000 degrees Celsius. Titan, Saturn's largest moon, is over 2,000 times larger than that comet, so the force of it alone colliding with Jupiter would be massive. If Jupiter and Saturn collided, they would begin to merge. Their atmospheres would mix. That would raise the temperatures in the top layers of the gas giant's atmospheres. It would get so hot that Jupiter would experience a chemical reaction, gaining more iron, silicates, and even water. Eventually, Jupiter would absorb Saturn, or most of it. Scientists at Sun Yat-sen University in China modeled a scenario about what happened when a massive planetary embryo, about 10 times the size of Earth, collided with Jupiter 4.5 billion years ago. The impact was so energetic that it destroyed Jupiter's original compact core. This formed a more diluted core composed of a dense mix of liquid metallic hydrogen and helium. But if Jupiter collided with Saturn, that event would be 10 times more massive. Large amounts of material would spread out in space, and then all that material would come together into a single planetary object.
we'd call it New Jupiter or Jupiternus. And maybe that new planet would cause more trouble in the solar system than you might expect. Jupiter is sometimes referred to as a failed star. That's because its size and composition are similar to a brown dwarf. But Jupiternus would be more massive and have higher internal pressure. If the temperature was high enough, this could cause nuclear fusion in its core. Yeah, Jupiternus could become a star. And the impact of having 2 stars in our planetary neighborhood would be huge. It could even mean the end of life on Earth. Now, don't worry, if these 2 planets merged, Jupiternus would have a mass 30% greater than Jupiter, but for nuclear fusion to ignite, the planet would need to reach a mass of 75 Jupiters. So, life on Earth would go on, but this would be a spectacular show with tons of gas and debris expelled. Maybe it would all be illuminated by the sun, giving us a beautiful, glittering end to Saturn as we know it. Jupiter, Uranus, Saturn, Earth? Sadly, the Earth didn't make it onto the list of the solar system's ringed planets. If it did, would it still be able to host life? This is What If, and here's what would happen if the Earth had rings like Saturn. When the Earth was young, it most likely had a ring of rock debris around it. 4.5 billion years ago, another planet, Theia, hit the Earth. The giant impact sent a ring of matter hurtling into the Earth's orbit, but it didn't stay like that for long. The rocky debris soon formed another celestial body, the one we now call the Moon. Having planetary rings visible in the sky would look way more spectacular than just one gray rock, right? Maybe, but if our planet got beautiful rings like these tomorrow, much of life on Earth might not survive the renovation process. It wouldn't necessarily take another collision to form rings around the Earth. We could just crumble the Moon, and for that, we'd only need to move it a little closer. The gravitational pull that our planet exerts on the Moon isn't equal everywhere. It's much stronger on the side of the Moon that is closest to us. There is a limit on how close celestial bodies can be to each other. It's called the Roche limit. If they get any closer than that limit, the larger body shreds the smaller one into pieces. The distance of the Roche limit depends on the size, mass, and density of the 2 objects. For instance, the Sun rips up comets that come within 1.3 million kilometers of it. The Earth will tear apart an average-sized comet from approximately 18,000 kilometers away. For the Moon, the Roche limit would be about 9,500 kilometers. The rings we might get from something the size of the Moon would be about 5,000 kilometers wide and around 9.5 kilometers thick. But unlike Saturn's icy rings, ours would be made of nothing but rock. The Earth is just too close to the Sun to keep the debris iced. Looking out at the sky, you'd be able to see these rings from Earth at all times. Because of the brightness of the rings, the Moon wouldn't seem as bright anymore. That is, if we still had the Moon. If the Moon crumbled up and became our rings, well, there'd be nothing else up there to look at. And there would be some other consequences. The rings suddenly hugging Earth would disrupt internal navigation systems of some animals. If not enough direct sunlight was making it through the rings, they would also affect photosynthesis and our oxygen supply. In the shadow of the rings with no contact from the sun's rays, the temperature would get so cold that it would make the shadowed areas of the Earth almost uninhabitable. Communications satellites, generally placed around the Earth's equator, would find themselves right in the middle of a rock storm. We'd need to find another way to keep the internet alive if we want to keep posting selfies on a ringed Earth. We'd be better off in a scenario where the Earth has always been like this. Provided we didn't lose sunlight and oxygen, we'd evolve just fine. But we'd have to develop other means of communication since we wouldn't be able to send satellites into an orbit full of rocks. Space would never become our final frontier. The rocky rings around the planet would be a sort of orbital barbed wire fence, keeping us all grounded. And just like the rings of Saturn, Earth's rings wouldn't last forever. One day, they'd start to feel their age and drop from the sky. Make sure to wear a helmet, and don't forget to look up and enjoy the show. If the multiverse is real, there might be a ringed Earth somewhere out there, with people on it wondering what it would be like to live on a planet with no rings. Well, that about does it for our survey of the seriously stupendous, stunning, semi-spherical, and spectacular sixth planet, Saturn. Thanks for joining me on this journey. You know we're going to do it again real soon. I love these marathons of magic hypotheticals, and I think you might too. We're in alignment, like the planets. I'll see you next time. Hey, fans of hypothetical scenarios and crazy compilations about the cosmos, it's another special What If episode. I mean, they're all special if you ask me. Today, we're focusing on the second largest planet